Welkom bij de Nederlandse Kubernetes podcast. De podcast over Kubernetes voor iedereen. Ik ben Ronald en ik zit zoals altijd met de enige, echte...
Hallo Ronald.
Jan Stomphorst. Welkom Jan.
Welkom Ronald. Nou, we zitten nog steeds in een hele mooie donkere ruimte. Weer een nieuwe gast.
Ja, die is net aangeschoven. En I would like to welcome Natan Yellin. Welkom.
Thank you. A pleasure to be here.
And for the people who don't know you, Nathan, can you please introduce yourself?
Yeah, so I'm an engineer by background. Today, CEO at Robusta DEV. And I guess I got started, seems like a very long time ago, back before there was much of a cloud other than the type that's actually up in the sky. And I got started with open source. Back in the day, there was a big battle between GNOME Linux and KDE Linux. Those were the two main desktop environments.
Yeah? Did they have a big battle then?
Oh, they were the greatest flame wars back then. It was almost like Emacs and Veeam. I don't even know what the term is in today's terms, like GKE versus EKS. Like OpenShift versus Rancher.
Oh, really?
Oh, yeah.
Okay. Yeah.
Well, those are both commercial, whereas GKE and GNOME were both open source. So those were the two big...
You've got two camps. You've got the KDE users, bit of quirky, more.
Yeah, he talked about the split. You know, that's what you... There was a split.
So I got pulled into the GNOME camp, really because I had just downloaded Ubuntu. When you download Ubuntu, it installs GNOME.
Still do.
No, didn't they do their own desktop environment?
Sometime, but it's back
They
at the blow.
switched back.
Yeah.
So I was actually they had a hackathon once at MIT in Boston, and Mark Shuttleworth came in, which was cool because it's kind of famous.
Yeah, he's cool.
I was actually where they decided they were going to do the split, I think, and go off and do their own thing. Of course, I was a nothing teenager who was involved in open source, and somehow I found myself waiting into the room with Mark Shuttleworth. It was cool, but at the time it was all over my head. Also the politics and the bigger vision as well. But it was very interesting. So I got started with open source, and then went some hackathons. And it's funny how small the open source world is. Back in the day, I worked a little bit on some open source software for GNOME. I was in high school at the time. I worked on it with a guy named Safe Lotfi. Now, if I go on the booth floor here, on the exhibition floor here at KubeCon, Safe is, I think, at CTO, but he's one of the founders of Axiom. Does really cheap blogging. It's like a small world. You bump into so many people. Fast forward many years. So that was my start in open source. And then for many years, I was in the cybersecurity space and got a degree at university, did a whole bunch of things and worked on low-level networking, wrote some eBPF bytecode by hand to make it super optimized. But of course, back then it was just BPF with no E. And interesting work. I did a lot of work as an engineer. And eventually I found myself at a startup doing Kubernetes security. And sometimes we'd have incidents and people would call and I'd get called during dinner, which of course I hate. Who does it? And get paged. And very often I'd have to help people and walk them through steps on how to troubleshoot something and say, okay, well, this error is occurring. Okay, well, let's go into Grafana. Let's open up the dashboard, go into this dashboard, look at these metrics, pull these logs, these traces. Let's look at this. And you then walking people through an investigation like that on the phone. And I kept saying oh man, there's got to be a way to not have people bother me during dinner.
And that's always a good reason, yeah.
And then Robusta was born of that, and we got started with automation. So an alert occurs, you snapshot the alert, pull in logs, pull in the metrics, pull in whatever is relevant for that alert, and then surface out to we did as an open source project, which is pretty popular. It's still growing pretty fast. And we've done a little bit of other stuff in the open source space with Kubernetes, like KRR, Kubernetes Resource Recommendation. We have a few other projects. And all those projects are about really what I call the biggest problem in cloud native and observability in general, which is that everyone has enough data. Oh my goodness. Everyone has enough data. And yet, when you walk around the floor here at KubeCon, big topic is, okay, well, how can we get in more data? Traces, metrics, logs, now EDI, BPF, driven stuff, right? Zero instrumentation. We gather up all these things. But I will tell you now, going back as an engineer, when I got called during dinner and we're troubleshooting these, we had all the data. I just had to walk through where to go and look at it. So to me, that's the biggest problem in space, and the space that, and the problem that I've dedicated my professional life and startup and really now put my career into solving is, how do we close the gap? There's a gap between the data we collect and between our ability to make meaningful insights out of that data. And I want to speak a little bit about platform engineering here. And this is very much often a platform engineering story. It's a platform engineering story for a lot of our customers as well. Every platform engineering team is going out there and they're building a platform to run their stuff on. And every platform engineering team, though, should be, if they're not, they should be very concerned all the time about how do you prove the value to the business.
Yeah.
Because otherwise your team isn't going to be around in 2 years.
No, sometimes a platform engineering builds a platform and the engineers need that their program doesn't fit that platform.
And then they don't use the platform. And then someone asks a question, well, why should I use your platform if I can go off and I can use EKS? EKS is a platform.
Yeah.
And EKS is a well-documented public platform, whereas your platform is something that's never been documented anywhere. So every platform engineer in the world should be focused on how do I show the ROI to the business. And platform engineering initiatives span a lot of parts across the software development lifecycle. So there's how do I vision, how do I template out new software, right? You have Backstage and you're using the scaffolder plugin, right? I'm generating a new application.
Mm-hmm.
And how do I get that application now that's in production, how do I observe that? How do I manage the cost and the FinOps on that? How do I do all those things? Today, just to scope this discussion, the earlier part of that, how you prove the ROI on that, I have some thoughts as well. We'll have to save that for another podcast. I want to focus on what happens after you get it and how you prove the ROI of your platform engineering team on day 2. And why am I focusing on day 2? Because there's a hell of a lot of day 2s. Because it's day 2 and day 3 and it's day 4 and day 5 and day on forever, whereas day 1 only happens once.
Yeah, and day 1 is fairly good documented.
Yes.
Everywhere.
Yes.
Where everybody says day 1 operations are installing, setting up, and those things. So installing Kubernetes is easy. Everybody wants to know it and everybody knows it. But day 2 operations is where your workload is on there.
And then what?
But this is the part the business cares about. Business doesn't even care. I mean, the business cares to some degree, but if you got your application up and running, you did so on the right time frame and the right time schedule. I don't care if it's on Kubernetes or, God forbid I say it, but Nomad or on a virtual machine, whatever. The application is running. But what matters to the business is the application reliable? Is there downtime? When there's downtime, how fast can we recover from that? What is the cost of ownership on that application? How big is the SRE team to support that? What incident response model do we have? Do we have a DevOps model where you build it, you run, and developers are responding to that? If so, do they have the necessary skills and necessary data to do so? Sometimes they have all the responsibility, but they have zero access because of limitations and they can't go and troubleshoot effectively. So how do we surface up give them the capability to troubleshoot effectively, right? How do you give them context without access? On day 2, you're worrying about observability, because observability really comes down to like the crux of what the business cares about is stuff running properly. And that is the big, big problem here. And the big problem here is that we're also focused on what the observability vendors want us to think about. Now, I'm not really an observability vendor, so I can say this. I don't store data. I don't store log. If you go to someone and they charge you for how much data you send them and how much data they store, of course, they want you to send and store more data. That's just the plain old incentives. But is there a correlation between the data you're sending and storing and between your ability to derive insights out of that during an incident? And that's where we have this huge gap in the business. And that's why I'm getting called up during dinner to go and troubleshoot things and point people in the right place and take them on this guided journey through Grafana and through dashboards. But all the data is there. So I would say to every platform team out there who is going and trying to prove the ROI on their platform, yes, let's get observability in place. Let's have logs, let's have metrics, let's have all those. But even if you only have 40% coverage, you don't have best instrumentation and everything. I would bet the data you need to resolve incidents is actually already right out there and it's in your data sources. If only the right person knew what to query. If only the right person knew what data to go and look at. And I think that's the area sometimes gets missed, that all the platform engineering teams should be focused on improving the ROI. In doing this initiative, have we been able to shorten incident response times? And to do that, you have to not just focus on getting all the data in, because you get all the data in, but then the developers never look at it.
But you need also people who understand that data. And that's...
But you can't change it. Like human nature is, people are what they are, and you can lift them up, and you can lift up people to a certain level. And like when we go into customers and we do enablement sessions on our product, like we'll show them how they can do that. And then we go and work with their customer teams. We're working with the platform engineering team, and they say, okay, our customer team's here. They could really use some help in seeing how to see the right data. And we help them show how to do the right data. But we go in and we do that enablement. We help those customers see why stuff is firing and learn. But can't take someone at a big enterprise who is fantastic at writing job applications on the app dev side has never dealt with cloud natives, been in the business for 30 years or 20 years. They really know the application, and you will never turn them into be the expert Kubernetes troubleshooter. And they shouldn't have to be. So you can lift people up and you can give them the tooling, but it can't fundamentally completely change the DNA. Like, you can help get them closer, and you have to make sure though that they have both the context and they have the knowledge and the motivation. And it's not too hard, because if it's too hard, they're going to fall back on you and your customer success team. And the way that always plays out is the customer success team, like the platform engineering team, gets overwhelmed. They pull in the customer success team. Then the customer success team gets overwhelmed. And now they move from people messaging on Microsoft Teams channel to putting in a ticketing system in place like ServiceNow or Jira to respond to tickets. And that gets overwhelmed. So like, you have to be able to empower people. Do that. You have to shift your mindset from thinking about how do we gather more observability data to how do we help people see what matters at the right time? How do we extract value out of the observability data?
Yeah, and how can we see that the application, like, for example, a pod is not working? How can we see what the problem is from that pod?
Well, if you were if you were a platform engineer, right, and you had access, then you would run kubectl, get pods, or describe pods, and whatever. You would look at it, and you would see it's an imageable backoff, and you would see, and you would know what that means. But your application developer often doesn't have access to the infrastructure, so we can't even run kubectl.
No.
And he often doesn't even know where to look, because it's not always just a pod issue. You're looking at a replica set. You get another in Slack, like deployment replicas mismatch. There's a mismatch on the replicas. You go look at the deployment or the replica set. It's fine. It's an issue with the pods. So you have to help surface that up in a way that makes sense for people. And you have to be able to also show them the right day at the right time. Because, like, let's say something goes wrong in the middle of the night, and then you come in the morning, the Kubernetes events that you could use to solve that are no longer around.
It's 2 hours. Standardly, you know,
hours.
Two standard hours, they're gone.
Maybe you persisted that to ELK. Okay, that's again the wrong mindset, because yeah, sure, your events are there in ELK or in Kibana or whatever, but does an engineer know how to go and look at it? So there has to be this huge shift in how we think about it, and the focus has to shift for like platform teams to be able to prove that ROI, to show and to reduce the times. Like, we have better infrastructure, we should be in a better place than we were before Kubernetes. But instead, sometimes we have more problems. You have to do that shift from how can we gather the data to how can we make that data accessible.
It got more difficult because back in the day, when I was young, we only had one Linux server. And
You look at the log files.
and that worked. And that was it.
Okay, I'll give you a simple example. Okay, we have an open source tool called KRR, Kubernetes Resource Recommender. It tells you what should be the request and limits for your memory and your CPU. That problem didn't exist before Kubernetes.
No, it was there, but it was...
No, I
different.
developed the application. I put it on the box. Either the box was big enough or the box wasn't big enough. If I had a high CPU, I bought a bigger box. But I didn't have to worry about, is one application running on that interfering with another application, another pod, and how provisioning it. And there's a whole level of complexity, because it's not just about how much... Before you'd ask one question, you ask how much CPU is each process on that box using.
Mm-hmm.
Now I'm asking 3 questions. I'm asking you, how much is it using? What is the request? So how is it being scheduled, right? Into which box? And then what is the limit? And where is that being upper capped? And what are the different implications between that? And then all sorts of scheduling questions as well. What happens when you go over? Well, actually, there's a rather complex step. Like, let's say you have 2 pods running on a machine and they're both over provisioned on memory.
Yeah.
And now they're both using too much memory. And there's a third one that's using actually under its memory limit. And now suddenly there isn't enough memory on the machine. Who gets killed? It's actually not so easy to answer. I read through the source code a few times. I looked through the Linux kernel and like start with secret. I'm not even sure who gets killed in some of those scenarios. There's a rather complex algorithm on that. And I've seen scenarios where I believe, and again, take this with a grain of salt, I believe I've seen an instance where the result of the algorithm is that the pod that's under its memory then is the one who gets killed because of other neighbors who are misbehaving. But it's not, it has to go into here also how priorities work and classes. Like, let's not go there, but
the Oom Killer is a different beast on itself, but it's awesome to. So if one or more processors on that machine goes out of memory, the machine decides which process to kill, and often that's the process you don't want to have killed.
yes.
Because it's always like that.
Yes.
Because it's often the process that uses the most bulk of memory, and that's often it's always your application. Yeah, so Oom Killer is fun. It keeps your machine alive, but it kills your application.
Yes.
Bij ACC-ICT staat alles in het teken van continuïteit waarborgen voor bedrijfskritische applicaties. Of het nu gaat over Managed OTAP, Cloud en Kubernetes, ze geven hier invulling aan om door samen met hun klanten een toekomstbestendige strategie uit te stippelen voor het gehele proces van ontwikkelen tot en met productie.
But it gets complex. But again, back in the day, you had one server. You look at the processor, which processor is using up the most memory. Now going to request and limits and stuff being scheduled to the same machine. Actually, the algorithm for who gets killed is a little bit trickier. So you have these problems between two different pods running on the same machine. Answering questions now is not as much as simple as saying, how much memory does this application need? It's how much memory does it need? How much capacity do I have on the nodes? Did I set up the expectation correctly on how much memory I'll need? That's your request, right? Did I set the limit to over, like, there's all these other aspects that go into it.
Do you set the limit in the request? What kind of...
It's very controversial.
How do you set them?
Meaning, what number you put is easy. Like, that's what we do with the open source KRR. We say take the maximum memory and then add on a certain threshold for safety. Because you can't... If you get memory wrong, you get killed.
Yeah.
CPU is easier because CPU is compressible. So
yeah, it's a compressible resource. And also, there are different opinions about that. But let's stick with memory.
Okay, let's stick with memory. So on memory, the approach we recommend that Tim Hawkins from Google recommends, and Tim Hawkins is the go-to guy on all this. If you ever want to have a podcast just on like what you should do on memory, request, and limits, like bring on Tim Hawkins. He's smarter than I am. And he wrote a lot of the code in Kubernetes that deals with this.
Yeah.
But the common philosophy that Tim Hawkins advises, which in my experience is a very good philosophy, is to set the request equal to the limit on memory and never to over-provision memory. But let's get back on topic to the observability. Because again, this is also an observability question, right? Everyone is gathering. Do you know how many teams have over-provisioned infrastructure by 60%, let's say? So the way this plays out is the developer comes and the developer says, Kubernetes, the platform engineer says to the developer, you have to say how much memory you're going to need on Kubernetes. So the developer says, okay. I mean, how does he know? He says 8 gigabytes. That's an 8 gigabytes. Now that reserves on the machine 8 gigabytes. There's 8 gigabytes that is reserved that cannot be used by other processes, at least from a scheduling perspective, right? So you could have a scenario where you have a machine with 8 gigabytes, let's say, and a pod that requests 8 gigabytes got scheduled to it. Nothing else will be scheduled to that machine. But the application is using 300 megabytes. And now you have a scenario where you have pending pods in your cluster, you're out capacity, but your utilization is at 0.
Yeah. Now, but
again,
I think that happens not once, that happens often.
There's a study from Sysdig. 69% of all workloads are over-provisioned.
Yeah.
There's a massive cost saving. Again, the funny thing is, all the observability data is there. Every single company I've ever seen that had massively over-provisioned workloads, they had the right metrics from cAdvisor being gathered and sitting there in Prometheus. If someone had looked at them, you'd say, I can save the company $500,000 a month. Depending on the size of your company, scale that up or scale that down. But the data is all there. Again, we've been so focused on getting in the right data, and I'm guilty of this as a former engineer. I want to get data. I want to gather the data. But how good are we at looking at that data and extracting the right insights and seeing the right data that means something? We need to stop focusing on gathering the data and start focusing on how we consume that data and whether we're getting value out of it.
But that's one of the reasons I think when you walk around the show floor, you see a lot of observability tools to take that out of the hands so that everybody can see it. But the data, what you're saying, the data is already available.
You will walk around the floor and you will see people saying you need to gather data with eBPF, and we will auto instrument, and we will do this and we will do that, and we will give you traces. Okay, fantastic. But no one's looking at it. You have all the data today. So if you have 10 more times data, why is someone going to look at that now? Because it's 10 times more data. That's a problem. That's 10 times harder. Your developers won't look at the logs today. Why are they going to look at traces?
Yeah, how do we solve that, Nat?
Part of it is cultural. Part of it is enablement, right? And I think there's been a lot of good talks, especially at previous KubeCons, about how you do that kind of enablement, how you go and you train the trainers in the platform initiative. So a big part of that is cultural.
Now, how do we change the culture then?
So the cultural part is hard, but yeah. I think there are things that you can do on the tooling side which make it easier to change the culture. And let's just start with base assumptions about human nature. Because human nature will never change. It's been the same for
Yeah.
However many millions of years. We've changed a little bit, presumably, in that time period, but we haven't changed in the past 10,000 years as like a species, right? So my wife can't even get me to remember to put my socks in the bin sometimes. It's hard to change human nature. We do
Yeah.
and I apologize to my wife. Well, it's really hard to change human nature. But so let's start with that assumption. And let's start with assumption number 2, that we kind of take the path of least resistance. And what I mean by that is water flows downhill.
Yeah.
Humans flow into the path of least resistance. And there's a lot of stuff in behavioral psychology around this, right? Like if I want you to eat healthy, if I want my kids to eat healthy, and every day they come home and on the table there's a bag of cookies, they're not going to eat healthy. If every day they come home and on the table there's a bag of carrot sticks or a platter with vegetables, they're going to eat healthier. It just is human nature. Water flows downhill. People do what is very accessible and easy, and they don't even think about it. They're not making a conscious decision today, I'm going to eat healthy. I mean, they're hungry. It's right there. It's accessible. That's what you do. If outside of your workplace, there's a McDonald's, you're going to eat. That's healthy on average than someone who has a salad bar right outside of the workplace. That's just human nature. You can't change that. So how do we as a platform engineering team make it easier for people to do the right thing while you surface it up? So if someone's looking at an incident, make sure that when they get that alert and they're looking at the incident, that the data is right there. So have a link right out to the traces. Have a link right out to the logs. Do some correlations. Show them so that when you are looking at something, it becomes easier to look at the data than it does to not look at the data because it's right there in front of you. Of course you're looking. Everyone has good intentions. Every developer wants to be empowered. If I have to go and I have to copy the name of the deployment, then look up the pods, then copy the name of the pod, and I have to go into ELK and put that in a weird search string, I'm not going to do it. If I look at another right there in the dirt are the logs, wonderful. I'm going to look at the logs. Of course I will. Human nature is like water. Water flows downhill. You got to make it easier for people to see the right data and to see that observability data than to remember that they have to go off and look at some other system, start to copy paste stuff to correlate. So you have to focus on how you make it really easy and accessible for people to see it and how you surface it up to them so that it's just there. They shouldn't have to think. They shouldn't have to remember. You shouldn't have to drive a change in their behavior. You should do the harder work, which is your job. And like what you can do as a platform team to be really enabling, you can make it possible for people to already have the context, so it's just there in front of them. Now people are going to look at it. Water flows downhill.
You solved that.
So we're doing work now with AI. I mean, this is... We've done two things to solve that. The first is we released an open source project called Robusta. That's on GitHub. And what we do is we take alerts, specifically Prometheus alerts, and we do snapshots or enrichment. So an alert comes in and pod crashes. We snapshot the log and we just attach it to the alert. Now someone gets the alert. They look right there in the alert in Microsoft Teams, or Slack, or Cisco WebEx, wherever it goes, or AppsGenie or PagerDuty, sent to all these different destinations. Yep. And just right there in the alert is the logs on that crashing application. So we take kind of like a proxy between Alert Manager and between the destinations it sends to. And we go and we snapshot logs, we snapshot pod crashes, I got Oom killed. We pull in a graph with the memory usage. Now you see the Oom kill, now you see the memory usage over time. Now you're closer to solving that problem and to investigating it, right? So we have this open source project that has these YAML rules on how you can define these snapshots, or these enrichments we call them, and these playbooks on how to automatically go capture extra data and attach it to the alert itself. So when someone looks at the alert, the data is all there. So that's an open source project that we're really proud of. That's in pretty wide use, and that anyone can go and get started with today.
That's awesome. Yep. And that's easy. If you install it, it installs in Kubernetes, I hope.
It installs in Kubernetes, so it's just a Helm chart. We do something that's a little bit weird, but we're going to change it soon probably. People love it or hate it, but I want to explain what it is and why we do it. When you install it, then you have to have Helm values, of course, to install it.
Yeah.
So we have a command line that you run. It runs either in a Docker container or as a Python script, and it will generate the Helm values for you. And people don't always get why we do it, because they just want, like, why can't I just handwrite the Helm values? Well, for Robusta to do anything, it has to send data to destinations. So you have to have a Microsoft Teams, like a webhook URL. You have to have a Slack API key. So you have to have these integrations set up. So the command line kind of helps you get it set up. It just auto-generates the Helm values that you can then take and use anywhere. The people often want to set out without that CLI. So I think we're going to make some changes there. And then they'll have to still probably run some CLI or something to get the right.
Or a web page, or
downhill. Yeah. I mean, that's why we did it to begin with. We thought we'd just run the CLI and they'll give you the Helm values, but then it turns out people sometimes have issues running it with Python in their local machine, and Python dependency management and versions is worse than DLL hell back in the day.
Yeah.
So, probably making some changes there real soon. But it's really easy to get up and running with. I think we used to have this contest where we did Robusta speedrunning, and if you record your YouTube videos showing yourself setting it up, then whoever had the record, we get a T-shirt or something. Now it was at 60 seconds or something. And that integrates with Prometheus or Thanos or Victoria Metrics.
And you need Thanos or Prometheus already running on your system, or there's an
option that does it all in one. So we can bundle Prometheus stack.
Yeah.
And then we change some of the defaults to be less surprising. Like by default, Prometheus stack doesn't have persistency on Alert Manager, which means that if Alert Manager restarts, then all the silences in Alert Manager disappear. So we change some of the default settings like that to be less surprising for people. But we just bundle Prometheus stack, which is the number one way that people install Prometheus. Or you disable that option, you just bring your own Prometheus and set up the integration out of the webhook.
But do you have what else do you do with Prometheus to make it better?
So one other thing that we do here that is still experimental, and that's using AI and large language models to surface up the right data. And what we found is that we can capture really common stuff just with the robust open source, right? Like if pod crashes, pulling information.
That's easy.
Image pull back off, pulling the logs, pulling the memory chart, there's an issue on the node, pulling a graph of the node details. Fine, we can do all that. But the other day, I downloaded a sample web application from Weaveworks. God bless them. And I wish things had turned out differently with Weaveworks and Flex. But I downloaded a sample application from Weaveworks called Slackshop. And I took the Slackshop and I installed it, and it didn't work. I went to the front-end pod and I browsed around, and it just suddenly crashed on me after I logged in. I viewed my cart and I looked into it. Turned out that the front-end server on the Slackshop was communicating with another microservice that ran MongoDB, and the MongoDB image was tagged as latest. So since Slackshop was released 4 years ago, the MongoDB version had updated, and Slackshop front-end pod in Node.js was communicating with it, and the client driver hadn't been updated, so the two were incompatible. And I found that because I looked in the Slackshop logs and I saw it in there, and I found that sort of thing. So that sort of thing, and to get a one line, you're saying Slackshop stopped working because it's using an outdated version of MongoDB, and the MongoDB in the cluster is actually a newer version because it's tagged as the latest image. That sort of thing, hard to do without AI. It's surprisingly easy to do with AI. So this is one of the demo scenarios we test on with this AI agent. And what we essentially did is we built an AI agent. This is the newer stuff we're working on. It's not yet public. Just to avoid confusion, we have something out there on GitHub that's called the Kubernetes ChatGPT bot. That's not this. So what I'm speaking about now is not that project that's on GitHub.
He's speaking into the future. Also,
we've run it with customers already. I'll tell you about that in a moment. But we've run it. It's already run in production. Really interesting real-world environments, and found some really interesting things. But to the degree I'm able to, I'll speak about that in just a moment. But what it does is, core concept is, it takes an alert, and it runs that alert through a large language model. Off the shelf, our preference is usually Azure with OpenAI, so you can set up your own private instance. And as I speak now, my team back home is benchmarking Mistral and Llama 2, which are two self-hosted models, to see where we can get the best performance. But we're really agnostic on the model side. So an alert comes in, and it runs through an initial analysis. Now, the alert itself doesn't contain the information you need, of course. Like, a pod crashed. In this case, the Slackshop pod crashed. Okay, well, you have to actually go and look at the logs behind the alert. So the AI agent looks at the alert, and it says, okay, what data, would a human take? What would a human do? What would a human now do in order to investigate? It would go off and so it pulls in the logs. It looks at the logs, and it sees this error in the logs with MongoDB on the orders DB microservice, right? So now it goes off, and now it looks at the orders DB microservice, just like a human. It's an iterative process. As a human, when you run an investigation, then you never, get a dump of information. You look at that information, you solve the problem. No, you go off, you pull other information. You're building a theory on why this is occurring. You keep on pulling data. You do an iterative investigation process. So the AI agent does an iterative investigation process each time, pulling from different data sources. Again, you probably have enough data.
Yeah.
It's just not accessible. But an AI agent can go and pull from the different data sources and run an automatic investigation process and then give you the end result. Here is, I like to call it the 3 R's: root cause analysis. Here's what happened and why. Recommendation, here's what you should do about that. And in some cases, we have some evidence that we can even do remediation. So to automatically go and open a pull request, or to really give you a button to fix the problem, or to do it automatically.
So this is some kind of time traveling. So you look at the pod crashes, you look back iteratively what happens to cause.
It's not time traveling.
Crash.
It's looking at more pods at the same time to...
Yeah, but I've heard another observability tool talking about something that they called time traveling.
We have something actually in our commercial product that we call time travel, where you can like take a Prometheus alert, and then there's a button that says travel back, like go to start point. You can travel back in time to the exact moment where it started occurring. And as part of that snapshot I mentioned, we have that open source snapshot feature where you can take an alert and then snapshot what happened at the same time. So the commercial product like surfaces everything in that snapshot at the exact moment where the alert fired.
Mm-hmm.
And then moving over to like what that looks then in the AI agent, which again, it's only in private beta now, but we'll speak about that in a moment. The AI agent does a really good job at correlating the times. Because when you're like, as a human, when you're running this investigation, now as a software engineer, I used to hate it. I have an error occurring on Kubernetes on a pod, and then if my logs were like an ELK, I have to copy, paste like the different labels, whatever, match that up, and I have to start querying, like doing the time queries as well to get a time query at the exact same like point in time. That drives me nuts as a human. A machine doesn't mind doing it though. So being able to query at the exact moment in time is also really powerful. But think of it as an orchestration layer or an agent that actually can pull from any data source. So it doesn't have its own data sources, because again, you have the data. It can run kubectl commands, but it can pull in data from Elasticsearch. It can pull in data from really anywhere that you can give an HTTP endpoint and say, well, pull data, like it can go and pull data. And the coolest part is that it's schema this, meaning when you look at an alert, the alert might have a label that says deployment equals foo, or it might have a label that says app equals foo, type equals deployment, right? There's a schema on the alerts, and that schema often doesn't match up across your different application development teams. But the cool thing about using LLMs is that you can go schema this. It'll look at it, it'll do analysis, it'll figure out this is the really Kubernetes resource, and then when it goes and it queries for logs or queries other stuff, it knows what to query, and you never had to go and define that.
Yeah.
So this is what gets me excited, and we rolled out recently on one of our paying customers as an experimental feature, and the customer said to me, I don't think today's a good day to test this. I said, why not? You have some alerts firing. He said, no, but those alerts are false positives. 5 minutes later, he called up and the team, one of their customer namespaces was down. There was a major issue there, and it had spotted that, and it said, this is the impact of that. And I can't go into much more detail, but it was a really interesting message.
That's interesting.
It took something and it traversed a web of Kubernetes objects. It found the root cause, found the impact, and it was able to say, this is impacting all these applications.
That's cool.
This is what it means. So we're really excited about it. And if I may, we want to talk to people who can take this.
Fire away.
This is still early. This is still kind of pre-commercial even, right?
Mm-hmm.
And we want to speak to people, have these Kubernetes environments, and it can do non-Kubernetes too. I mean, that's the nice thing about this agent approach. You just give access to the right data. But we want to speak to people who have a decent number of incidents and who are interested in speeding up the time to respond to those incidents. People, when you say, okay, every incident that comes in, I will give you a one-liner showing the root cause, and I will tell you the impact, and I would do that. And your team that looks at that, they will have that all pre-filled in. So you get a JIRA ticker, you get whatever, you have an incident that comes in. By the time a human looks at it, it'll have in there an explanation of what is the cause and what you should be looking at, and it will give you the supporting data. Of course, you can't just say that. You have to show me the supporting data so you can go and verify that, right?
Yeah.
We'll show you the supporting data, and we can kickstart your investigation process. We're looking for people who get excited about that and have enough like alerts in the real world, and they're interested in trying this out and seeing the value on it, and who can work with us and give us the feedback that we need on a relatively early project. We have other stuff that's a lot more mature, but this is relatively early project to really help us close that gap between the observability data that is being gathered and what is getting sent out there. And we'll do that with the right people who want to work with us, but we'll do that like at the current stage free of charge. Like we don't want money. We just want to work with you, and we want to like really get this to.
Sure. Then where can they find you? How can they contact you if they want to start with this?
I'm Natan Yellin on LinkedIn and on Twitter, AANTN, which is just my first name, Natan scrambled up.
Okay.
Which seemed like a good idea back in those open source days when I was 13 and now confuses everyone. And me.
On robusta.com?
Yeah, we'll put a link in the
Robusta.dev. Okay,
Yeah,
awesome.
it's best to reach out to me personally on LinkedIn or on Twitter. And we can do full on-premise for everything I'm describing. And we really want to help everyone not get cold during dinner.
Well, that's a good thing.
That's a really good thing.
So, we always have a final question, so that's not to take more of your time, precious time today. How do you see the future of Kubernetes?
And Robusta.
Yeah, Robusta, of course.
Well, I've spoken enough about the future of Robusta.
Yeah, okay.
If it's okay if I only answer in Kubernetes.
Yeah,
sure.
I think we're going to see that hopefully Kubernetes will fulfill the promise of declarative infrastructure. And what I mean by that is Kubernetes, you give Kubernetes a manifest, and then you say, I want my application to do X, Y, and Z. I want my application to run. I want to do this. And I want it to be auto-scale or whatever. And then in an ideal world, you declare that, and Kubernetes goes off and does that. It reconciles and does all of its stuff. And you never have to worry about the how or the why or like what's going on under the hood. Today, there's still cases where there's a problem and Kubernetes doesn't surface up to you in a good enough way. And then you have to go and you have to troubleshoot the how and the why and the other things. And I think what like really excites me in the Kubernetes space is getting to a point where you really can like just give the declarative files. Now thinking I'm back to application developers and platform teams, where your application developers can know Kubernetes as an API. Your application developers can know there's a Kubernetes manifest for deployment. These are the fields I fill in. You don't even have to know that. Maybe they just put in the higher level abstraction or Helm chart or values or whatever. But they can fill in Kubernetes as an API and not care at all about what goes on under the hood. All developers should know about Kubernetes, if at all, is the API, right? This is the API. This is what you're promising me. Put in this YAML field I want through your replicas. You will have through your replicas. And if you don't, then I will surface up the issues to you. We want to get to a place where I think, maybe this is controversial, but I think developers should be okay knowing Kubernetes as the API and the declarative promise there, what they're requesting from Kubernetes, because that's okay. You want this image to run. I guess that does mean developers have to know containers, which is some challenging in some organizations, but I think that is a reasonable place for the future where everyone wants to be. That is empowering for developers. And put in there how many replicas we want. Put in there the other scan. Tell Kubernetes how your app should behave. You never need to know more than that on the underlying components and other things going on. I think that's the promise of Kubernetes. And I think we are getting closer and closer to that, to developers having to deal with like how Kubernetes reaches that desired state and the bumps it has along the way.
Okay.
Awesome.
Interesting stuff.
Awesome.
We're going to follow this development very closely because I've learned a lot today. And I want to know more. But we do the next podcast where we have more time and we can go more in depth. So, Nathan, thank you again for your time. And we hope to talk to you again in the future.
It's been a pleasure. Thank you so much for having me.
Thank you very much.
Deze podcast is een initiatief van ACC ICT en wij zijn te beluisteren op onze website k8spodcast.nl via Spotify, Apple, Google Podcast en alle andere favoriete podcastproviders.